Let's start with the second part of the problem sessions and the third part of rotational motion series video. So let's start with the question. Consider a system of two particles having mass m1 and m2. If the particle of mass m1 is pushed towards the center of the particles through a distance d, by what distance the particle of m2 move so as to keep the center of mass of the particle at the original position? Main things are highlighted in the question. It's a two particle system, m1 and m2, and m1 is pushed through a distance d meter. How much m2 should move so as to keep the center of mass at the original position? This is the meaning of this question. Let's answer this. And I have depicted this as a diagram. We have a m1 body and we have a m2 body. M1 body moved a distance called d. How much m2 body should move? Here I have put an arrow mark towards left. You can either put it to right side. Depends upon the answer. If answer is negative, which indicate m2 should move towards left. If answer is positive, then m2 should move right. This value actually we have to find it out. Okay, now we know the general equation of center of mass. Already have written xcm equal to m1 x1 plus m2 x2 whole divided by m1 plus m2. We already seen in the last part of the video the shift. Shift means difference of distance, which is nothing but dxcm. Dxcm means shift in the center of mass equal to m1 into dx1 plus m2 into dx2 whole divided by m1 plus m2. So in our question, is there is any shift in the center of mass? No. So this parameter is 0. There is no shift in the center of mass. So how we can write this formula, balance formula? We are writing m1 into dx1 plus m2 into dx2 equal to 0, because if m1 m2 is multiplied to this left hand side, this will totally goes to 0. The numerator is equal to 0, which means now we know m1. How much is the distance moved by m1 from its original position? M1 is now initially will be here and it is moved through a distance of d meters. So m1 into d plus m2 into how much the distance moved by m2. That is the real question we want to be find out. So instead of the question mark, I am placing it as dx2. This is what we need to be find out. So this is equal to 0. We know dx2 equal to minus m1d whole divided by m2. So this is the distance moved. As I told before, you can see one negative signs will be here. So negative signs indicate this d distance moved by m1 is towards right side, and this negative signs indicate the dx2 is towards left side. So question is not asking whether it is towards right side I have to move or towards left side we have to move. Question is not asking the direction of the motion, but question is only asking what is the value of this one. So value is m1d divided by m2 is the answer. If from JEE questions kind of examination, it might ask like at what direction it should move. So it is moving towards left side because of this negative signs. Yes, our answers are matching with option B, m1d divided by m2. So option B is the right answer here. Let's move to the 9th question. A T-shaped object with the dimension as shown in the figure is lying on a smooth floor. A force capital F is applied at the point P parallel to AB such that the object has only translational motion and no rotational motion. So find the location of P with respect to the point C. So let's analyze the question. A T-shaped structure is given in the question and a leg, and we can consider something like a body, and we are applying a force F at the point P, and the force is applying parallel to the body AB. Question is given a major hint saying like that the object has only translational motion and no rotation. This is a key point in the question. So what this means to us? Let's consider a disk. Okay, so disk, we know the center of mass is at the center. If I'm applying one force at the disk center, at the center of mass point, the disk will move downward direction, which means linear motion. It is also called translational motion. But instead of you are applying a force exactly at the center, suppose you apply a force at this point, then what will happen to the disk? Disk will undergo a twist, or we can say a turning effect. That is nothing but it is called a torque. Same way, if you apply force on the other side, maybe here, what will happen? This disk will again rotate in this direction. So this means if you are applying a force any other point other than center of mass, the center point is here is the center of mass. So if you are applying a force other than center of mass point, then the body will undergo rotational motion instead of translational motion. Translational motion also may happen, depends upon the amount of forces which may both undergo rotational and translational motion. But if you are applying a force exactly at the center, the body will only undergo translational motion and no rotational motion. So the question here is aiming us to find out the point P. It is lying with respect to C. With respect to C, from here, where is this point P is located? What is this point? Is actually, it is a center of mass point. So we need to find out the center of mass point, which is at the point P. That is the meaning of this question. Okay. 4 options are given: 4 by 3 L, L, 2 by 3L, and 3 by 2L. So we'll go ahead. Let me redraw the diagram again. Okay. So we have a T-shaped structure like this. Okay. And the force is applying at this point. This is of length 2L, and this is of length L, and this is nothing but A. Okay, now we want to find out the center of masses. So this structure we can consider as a 2 masses system. Okay, because we know one leg will be there and one body will be there. So I consider this as a 2-point system. For example, this is a first body, which I have marked as just a circle will be here. Okay, and we have this this leg part is considered this bottom one. Just for our understanding, I am giving number 1, and the above one, the body, is marking another mass. For my understanding, I am giving number 2. Next, the question is like, what is the distance or the displacement between the number 1 and number 2? What will be the displacement? Displacement means the distance between the 2 bodies, which is also from center to center distance. What is the center distance will be here? It is starting from L. Okay, and here L, because the total length is 2L, so the center point should be always at 2L. It may be above the F or below F, that we don't know. That's not given in the question. Actually, our aim is to find out the point P in the question. Okay, so I know the center of the first rod, the leg rod, is at this point, at some point. It may be above or below, but I don't know. But one thing I know, the center to center distance. So this center will be here, for example, and the centers will be here, for example. Then what is the center to center distance? Here is nothing but L. Okay, I'll draw the leg a little more length so that it will be exactly at the center. Now the center of this leg to the center of this body, the distance is L meters. Okay, now I am considering this as M1 body, I am considering this as M2 body. Now we'll find what is the value of M1 and M2. We know 2 rods will be given, both are the uniform structure, and this will have a length equal to L, and this will have a length equal to 2L. Okay, if for example, for a body which having length L, I am assuming having a mass of M kilogram. For a body having mass 2L, means just to double the length, definitely it should be also 2 kilogram. In this case, we have replaced the diagram, and the leg is corresponding to M1. Leg length is 2L. So our M1 will be equal to 2M. And M2 is corresponding to the body. What is the length of the body? L. What is the corresponding mass will be here? M kilogram. So M2 is nothing but M kilogram. This is 2M kilogram. That's all. Okay, now we have two bodies, M1 body, M2 body, separated by a distance of L. How we will find the center of masses? I already described this concept in the previous problem. If we have two bodies will be there. I'll repeat it once again just for to get some insight into that concept. So M1 body, M2 body, distance between them is D. Then RCM is the center of mass distance from the first body. How will calculate RCM? RCM equal to mass of the second body, means next body, into distance between them divided by total mass, M1 plus M2. These concepts we are going to apply will be here. We will apply this concept will be here, and we'll see what's coming. So M1 is first body. So I'm basically going to find out this distance. This is nothing but RCM. So I'm writing RCM from the lower body equal to mass of the second body. What is the second body mass will be here? It is nothing but M kilogram. Kilogram I'm not writing, M. Into distance between the two bodies. What's the distance between the two bodies? It's nothing but L. All divided by sum of the two masses, 2M plus M. So totally how much will come? 3M. So answer is nothing but L by 3. Now we got L by 3. What this means? L by 3 is the distance of from the leg center point. So I am only drawing the leg part will be here. So this is nothing but the leg part, C point. So we know the respective half distance. So bottom distance is nothing but L, and we have a upper distance also equal to L. But where will be the center of mass is located? From the center at a distance of L by 3. So question is asking what is the distance of the center of mass, which means the point P. So here basically we are applying the force called F. So this is at what distances from the bottom? What is the total distances will be here? Already L will be here. So we are adding L by 3. So which is nothing but L plus L by 3. Nothing but 4L by 3 or 4 by 3 times of L. This is the distances from the bottom point to the point at which we are applying the force. In the question, answer is 4 by 3 times of L, option A. Let's move to the 10th question. A circular disc of radius R is removed from a bigger circular disc of radius 2R such that circumference of the disc coincide. Center of mass of the disc is now alpha R, alpha times R, from the center of the bigger disc. The value of R is. This type of questions are very commonly asking question. Normally if you have a bigger circle, from the bigger circle, if something is removed from the system or from the system of particle system, what will be the new center of mass point? Okay, 4 options are given: 1 by 3, 1 by 2, 1 by 6 and 1 by 4. Let's analyze the answer. Okay. So let's go ahead with the answers. First we'll depict the diagram. We have a body and whose radius will be equal to 2R. It's nothing but a bigger circle. From there a small piece will be cut and removed from this disc, and that disc radius is nothing but half of this one, which is called R. So if you have removed this portion, then we only have the shaded portion. This is nothing but the remaining portion. This is the portion only remaining. This we can consider as a two body cases. One is the bigger body and another one is this hole which is made will be here. But the main concerns will be here. This is the hole which is created, which means a mass is something which is removed from the system. So to find out center of masses point, what we can do means you just draw a line like this one. This is what we want to do. So you make the bigger circle in a Cartesian coordinate system, which means in an XY axis you make it. So what is the center point for you? 0, 0. Here you are creating or you are removing some portion from here. So what will be this coordinate? Of course, you know half of this one will be r. So what is the coordinate of this one? R, 0. Okay, now you consider this as x1, y1, and you consider this as x2, y2. That's all. Now we know the general formula for center of mass. We know y coordinates will be here 0, y1 also 0, y2 also 0. So only x coordinate is important. So we can find out xcm, x center of masses. Let's do that. So x center of masses, you know, m1 x1 plus m2 x2 divided by m1 plus m2. This is a formula. This is the formula we are finding to find out the center of masses of two bodies. But here the difference to this formula here is, here m1 is a bigger circle and m2 is the body or the disk portion which is removed from this bigger disk of radius 2r. So m2 is something which is removed from this one. So instead of coming here, we have to place minus in the numerator and minus in the denominator because m2 masses are removing. Okay, two cases the plus become minus will come. One, x1 is a displacement and x2 is a displacement. If displacements are in opposite direction, then this sign conventions will come. In another way, if m2 is the second body is removed from the first body, also minus will come. So depends upon the question, we have to decide what formula we are applying. So here m2 is removing from the system. So both the numerator have minus and denominator have minus. Now we'll substitute the values. m1 value. To find out the m1 value and to find out m2 value, let's go with a general method. General method in the sense, normally if we have a body of mass 2r, what will be this is like a disk is like there are three type of distributions are there in all our physics. We call it as linear distribution. Linear distribution is nothing but a rod. I mean something like a L. We can measure its length. And we have surface distribution, something like a disk, we can say its area. And we have a volume distribution. This is something like a cube. Okay, so I can say like this is like a 1D structure. Either I can place a rod in an x-axis or I can place it in an y-axis. But this is like a surface kind of nature. So for this is associated with the surface nature, and this will have a three-dimensional structure which is represented with the volumetric distribution. So three distributions are there: linear distribution, surface distributions and volume distribution. If it is surface distribution, then the mass is changing in accordance with area. If it is volumetric distribution, then mass is changing in accordance with volume. If it is linear distribution, then mass is changing accordance with the length. In the previous cases we have seen, we have a T-shaped structure. What this means to us, in a T-shaped structures, we have mass is changing in accordance with length because it's a linear distribution. Now in this question is a disk, so mass is changing in accordance with area. Okay, so what will be the area in these cases? Now we have a bigger circle 2r. What is the area of this one? Normally the area is pi r square. So r means what will be here? 2r. So it become 4r square. Okay. And the smaller circle, what is the radius of this one? R. What is the corresponding area? Pi r square. To make the calculation easier, I know it is pi 4r square. This pi 4r square is 4 times that of pi r square. Now if I am taking this mass as 4m kilogram, what will be this mass? This is nothing but m kilogram. 4 pi r square is 4m. Then what is 1 pi r square? It is nothing but m. So how the pi r square into 4, what multiplication the first factor is coming, that is taken as a mass for this one. So 4 pi r square is 4m, then pi r square is m. How I put it as 4m in a very simple way means pi r square, if you multiply a number called 4, you will get this one. So that 4 will come as a mass for this one. Now we have two masses. Our m1 is a bigger body, has mass 4m kilogram, and M2 is a smaller body, its mass is m kilogram. Let's go and substitute. Now I am rewriting the formula xcm equal to m1 x1 minus m2 x2 divided by m1 minus m2. Hope you understood why minus is came, because we are removing from the system. So m1 mass, bigger circle 4m mass, its x coordinate is 0, minus m2 is a second body which is removing from, what is the x coordinate, r, whole divided by m1 minus m2, which is 4m minus m. So this part is 0, minus mr divided by 3m. M got cancel, we got minus r by 3. Question is asking, this center of mass is equal to alpha times of r. So what is alpha will be here? Alpha will be equal to minus 1 by 3. What is this minus signs indicate for us? Minus signs indicate the center of mass is shifting towards the left. We have a structure like this one and a body which is removed from this one, and the shaded portion is the removed area. The remaining area. So earlier the center of mass will be here at 0, 0 coordinate. Now it is shifted towards left, a distance of 1 by 3 times of radius distance. Of course we know here it is a hole, so less mass. Here it is a solid mass. So definitely the center of mass will shift towards the higher mass area. That is also another concept. So it is shifting towards the left side. That's what the negative sign will be coming. So if I take in the modulus value, without considering the negative direction, I told this x1 and x2 are the displacements. So displacement is a vector quantity. It will have sign conventions. So in this case, negative sign indicate it is moving towards left. Okay, so without direction, if I can say 1 by 3, alpha equal to 1 by 3. Next question. Two bodies of different masses, 2 kg, 4 kg, are moving with a velocity 20 meter per second and 10 meter per second towards each other due to gravitational attraction, which means there is no external force. What is the velocity of their center of masses? Question is very straightforward. We know the center of mass formula, xcm equal to m1 x1 plus m2 x2 divided by m1 plus m2. Question is given in not in terms of distance, question is given in terms of velocity. So from the displacement or from the distance, how will get velocity? We have to differentiate. If you are differentiating here, what you will get? dxcm by dt, dx1 by dt, dx2 by dt. What is all these quantities? Dx by dt, what is generally called? It's called velocity. So this has become velocity of center of mass will be equal to m1 v1 minus m2 v2. Why minus is coming? Because question is saying both are moving towards each other, which means if m1 is moving towards right and m2 will be moving towards left. So v1 and v2 are velocities which are vector quantities and both are moving in opposite direction. That's what v2 will have a negative sign here. Divide by any negative signs at the denominator negative signs, when it will come? It will come when some masses are removed. Here no masses are not removing, so there is no negative sign. This is just plus. Now we'll substitute. m1 is 2 kg and its velocity is 20 minus 4 kg velocity is 10 divided by 4 plus 2 6. Numerator itself it is 0, 40 minus 40, so answer is 0. Now we'll go and check the options. Answer is option D, 0. This is a straightforward question. This question may ask in terms of acceleration also. If it is acceleration, the same question is repeated with acceleration. So you can say ACM equal to m1 v1 minus m2 a2. Minus will come if both are moving in opposite direction, else it is plus, and divided by m1 plus m2. So remember the displacement version, velocity version and acceleration versions. Let's move to the 12th question. Small disc 2 cm is cut from a disc of radius 6 cm. If the distance between their centers is 3.2 cm, what is the shift in the center of masses? Here, this is similar to our previous question. We have a bigger disc radius 6 centimeter, and a 2 centimeter disc is cut and removed, and the distance between these 2 points are like 3.2 centimeter. What is the shift in the center of masses? Previously we have seen one question something like alpha r, what is the value of alpha? The same way this question, but one point which is missing in the question, and one thing we have to assume is like the portion which is cut and removed should pass us through the circumference of the disc. Actually that information is missing, and we can assume that, and we can go ahead with this answers for this one. Else anybody can cut any 2 centimeter sections from anywhere, either in the center or in the circumferences, anywhere can cut, but such information is actually missing in the question, so we are assuming it's passing through the circumference of the disc, and we'll find out the answers. So let's move. So we have a disc and whose radius will be equal to 6 centimeter, and another circle which is got removed, and the distance between their centers to this centers is nothing but given 3.2 centimeter. So we are asked like the previous question, this is considers the first body M1 and the whole is considers the second body M2. So this much portion is got removed. So earlier we have written the formula M1 x1 minus, because it is removing, M2 the center of mass xcm equal to M2 x2 whole divided by M1 minus M2. M1 minus M2. What is the mass of M1? M1 body will have 6r radius. 6r radius means how much will come the answer? So it is 36 pi r square will be the area. M2 body will have a radius will be equal to 2 centimeter. So what will be the corresponding? It is pi into r square. Okay, here r I am considering as like 2 times of r. 2 times of r if I am considering, or I can, or if I am considering r radius will be equal to 2 centimeter, then how much will come? Pi 4 r square. This is one way you can consider. The another way you can consider, for a bigger circle, radius r will be equal to 6. So how much is the area will come? 36 pi. You can consider like this one. And smaller circle with the radius will be equal to 2 centimeter. This is 6 centimeter. What will be the area will come? 4 pi. The masses of this one considers m, or I can take it as this is like 34 into 9 is 36. So I am considering as 9m. So in that case, what is the value of this one? It is nothing but m. The center point of the bigger sphere is 0, 0, and this position coordinate, what is the respective position coordinate? X is 3.2, y is 0. So we are substituting the value x coordinate of the bigger sphere. It is 0 minus second body m2. What is the mass of the second body is called m into its coordinate. It is nothing but 3.2 whole divided by 9m minus m. So the answer is m got cancels from everywhere. So minus 3.2 divided by 8. Answer is minus 0.4. So all are given in terms of centimeters. So our answer is also in centimeters. Now we'll go and see it is matches with our option A, 0.4 centimeters. And the negative signs indicate in the options, which means it is moving, as like I told in the previous question also, the same way. This is the original center of masses point, and now it is moving towards left side by a distance of 0.4, and the negative signs indicate this is moving towards left. That means which is towards the higher mass of the body. We'll move to the 13th problem. The density of a non-uniform rod of length 1 meter is given by rho of x, a into 1 plus bx square. It's something like a quadratic equations where a and b are constant and 0 less than x less than or equal to 1, which means the x value can be 0 or maximum value 1 or in between any values. The center of mass of the rod is. This is what I have mentioned while discussing the part 1 video of rotational motion. Continuous body distributions. So the density of a non-uniform rod, so it is not like a two particle system like M1, M2. I cannot separate something like M1 body, M2 body, M3 body. I cannot separate. Instead, they have given some equations. So this is like a linear mass density, which means the rod density, which means mass per length, will be changing according to the equation. For example, if I am telling, if I am considering a rod which is from 0 to 1 meter length. So if you are going from 0 meter, if you are substituting rho of 0, what you will get? A into 1 plus B0, which means nothing but A. So its density is A. So which means if you are changing the X value every time will be here, you will get different values, which means the masses of the system, this is mass density, mass per length, this is not constant, it's every point it is changing. In that case, I have told we have another equations for a non-uniform continuous bodies. We have a center of mass equations. That equations will apply and find the answers will be here. Let's go ahead with the answers. We know it's given rho of x will be equal to a into 1 plus bx square. The limit of x, the value of x is ranging from 0 to 1. So we know the center of mass formula equal to integral 0 to 1, the limit dm into x distance whole divided dm distance divided by integral 0 to 1 into dm. So this is basically the formula which we are going to have dm into dx, because dm mass is for dx distances. We'll apply this one and we'll simplify, that's all. So 0 to 1 is a limit a into 1 plus bx square into dx. Let's move to the solution. Before that, I will write the equations again. Rho of x will be equal to a into 1 plus bx square. So now we have the formula center of mass xcm equal to integral 0 to its length, which means the limit. So x limit from 0 to 1 into the formula, general formula I am writing x dm whole divide dm into dx whole divided by, we are integrating with respect to dx, integral 0 to 1, only the mass in the denominator into dx, differentiating with respect to, integrating with respect to dx. We'll substitute the values for this one will be here. So 0 to 1 x into a into 1 plus bx square into dx whole divided by integral 0 to 1 a into 1 plus bx square into dx. Numerator I am expanding and integrating at the same instant. The first factor is ax. So integral 0 to 1 ax, 1 factor integral 0 to 1. The second factor is what? Ax we are multiplying. The second factor is x is common, so the first term is a plus bx square will come, so ax is the first term. Second term is x a b x square, so which means a b x cube. So all are integrating with respect to dx, so whole divided by integral 0 to 1 into a dx plus a bx square dx. Here also integral 0 to 1. We have to simplify this using integrations. Well, go ahead. So ax dx, so it become ax square by 2, integration limit 0 to 1 plus abx power 4 divided by 4, integration limit 0 to 1, ax integral limit 0 to 1 plus abx cube by 3, integration limit 0 to 1. So we'll apply the limit and we'll say, if you are applying 0 limit, nothing, all will get cancelled. So upper limit we can apply and simplify it. So it's a by 2 plus ab divided by 4 whole divided by a plus AB divided by 3. So in the numerator part, A can take an outside, denominator part also A can take outside, so A will get cancels. And what balance will come? 1 by 2 plus 1 by 4 divided by 1 plus 1 by 3. Here 4 I am taking LCM, and in additionally what we have will be here. We have a B will be here, we have a B will be here. Now we'll simplify in the further step. So 3 is taken to the numerator. So and here I am taking 4 as LCM. I think that will be the quite fastest way. So 4 is taking LCM will be here. So 4 to 2 times. So 2 plus B whole divided by the last step. 3 is taken as the LCMs will be here. So what will come? 3 plus 1, and here 1 means 1B whole divided by 3. So 3 will go to the numerator and rest of the things will come to the denominators, and we'll see. So 3 into 2 plus B whole divided by 3 into 2 plus B whole divided by 4 into 3 plus B. We'll go to the question and we'll check whether we are getting the same answer. 3 by 4, 2 plus B, 3 plus B is matching with option A. So this is the answer. So remember this concept for a non-uniform continuous body. Non-uniform means if you are moving from one point to another point, the masses is keep on changing. So this is, I think if I remember correctly, this is the 5th point in the part 1 video. So if you have any confusion, just go and see that video and come back to this question so that it will be more clear for you. We'll move to the 14th question. A thin rod of length L lying along the x-axis with its end at x equal to 0 and x equal to L. Its linear density varies as. So again it is it's similar to the previous question. Its density, linear density is changing based on some formula k into x by L into all power n, where n can be 0 or any other positive numbers. The position of the center of mass of the rod is xcm is plotted against an xcm versus n graph. Which of the following graph best approximate the dependency of xcm? So it's nothing but we have to find out the center of masses with respect to n. We have to analyze this one. Let's have a look into these options. So for options, we can see xcm is on y-axis and n will be on, sorry, xcm is on y-axis and n will be on x-axis, and 4 options will be given, and we have to find out which one will be matches with our final expressions. Let's go to the answers and see. Let's try to solve this one. I'll rewrite the equations which is already given. Rho of x will be equal to k into x divided by L whole power n. This is a density formula which is given, linear density formula. We'll substitute to find out the center of masses. xcm will be equal to integral 0 to its limit length into, I'll write the formula once again, x dm integrating with respect to dx divided by integral 0 to L its limit into dm into dx. I'll make the pages as 2 part. We'll answer both sides. Okay, we'll start from here. xcm, x center of mass, integral 0 to L x into dm. dm means x into k into x by L whole power n into dx whole divided by integral 0 to L into dm into dx. I am substituting for dm in the denominator part. 0 to L x k x by L whole power n into dx whole divided by denominator side. We can substitute in the denominator part, and we got 0 L k into x by L whole power n into dx. Okay, so let's try to solve this integrations part. Here we are integrating with respect to x. Now I'll continue from here on the right hand side. Here you can see here x means x power 1, x power n. So what is the total x powers will come here? X raised to n and x raised to 1, which is x raised to n plus 1. So k is a constant, take it out of this integrations part. So 0 to L x power n plus 1 divided by L into dx whole divided by L also have power L power n. So k is out of the integration here also, 0 to L, and here only x raised to n divided by L power n dx. We know k can also cancel. L power n, we are integrating with respect to dx, not with respect to L. So L power n can also take it out of the integration, hence it is got cancelled. So the rest of the steps will be, we are integrating. L power n also, assuming it's cancelled, because this can also take it as out of integration, because we are differentiating with respect to x. What is x raised to n plus 1 integral? X raised to n plus 1 whole divided by n plus 1 means 2 whole divided by, in the denominator we are integrating x raised to n plus 1 divided by n plus 1. X raised to n integral is x raised to n plus 1. We are applying the limit. 0 to L will be here and 0 to L will be here. So while applying the limits, we are getting x raised to n plus 2. So we, instead of x, we'll put L. So L power n plus 2 divided by n plus 2 whole divided by, what we are getting further in the denominator part also, L power n plus 1 divided by n plus 1. We'll simplify the further steps and the equations become n plus 1 divided by n plus 2 into L power n plus 2 divided by L power n plus 1. Okay, what is L power n plus 2 divided by L power n plus 1? This we can written as n plus 2. The denominator, if you take into numerator, it become n plus 2 minus n minus of n plus 1. Okay, so denominator we are pushing to the numerator, so the power become negative. So we'll further simplify these steps. Yeah, let's move. So we can simplify for L. So now the steps become n plus 1 divided by n plus 2 into L raised to n plus 2 minus of n plus 1. So now how this formula will be, changes will be here. So this will give rise to n plus 1 divided by n plus 2 into answer is L. Now question is given, n will have a value starting from 0 to any positive number. So I am considering two extreme case. N may be 0 one case or n may be infinity in another case. If n is equal to 0, what is the value of this one? 0 plus 1 and 0 plus 2. So numerator become 1 by 2 times of L will come. If n is equal to infinity, infinity divided by infinity will come. Infinity plus 1, infinity. Infinity plus 2, infinity. So infinity by infinity is 1. 1 into L become L. So we know if you are plotting some graph, we know if you are plotting from graph XCM, X center of mass with respect to n. So the graph should start from when n value equal to 0. Graph should start from where? L by 2, and where it should go? It has to go to a value called L, but it's not constant. It has to increase, and it's going to L, and for any infinite value it is still remains constant. So here it is constant, here it is not constant. Immediately for each values it's keep on increasing and then it is remains constant. That is the meaning. Now we'll look back to the answers. We'll see what our answers are matching with this one. Yes, our answer is matching with option D. Option C and option D are more or less similar, but here it is constant. As I told, it's not constant, it's keep on increasing. Okay, it is this value might be always increases and remains constant. So answer D matches with this option. Let's move to the final question of this center of mass concept based questions. Two masses m1 and m2, m1 greater than m2, are connected by a massless and inextensible string passed over a massless pulley. Acceleration of the center of masses. This question in the initial look, which is more or less similar to the concept what we have learned from laws of motion. It's a pulley system. Two masses are connected over the pulley. One mass is m1, another mass is m2, m1 greater than m2. Now the acceleration, the question is not the acceleration of the system, acceleration of the center of mass of the body. 4 options are given. We'll go and check which one is matches with our requirements. Let's make this as a diagram first. M1, M2 body. We know M1 greater than M2. This is a pulley which is frictionless and inextensible string is connected over it. Next, from the laws of motion concept, we have one formula. It's a kind of shortcut formula to find out the acceleration of this kind of system. While I'm uploading such videos, you will get to know how to handle that one in the future. And right now I'll directly go to that formula. We know the acceleration of this kind of system, it is forward force minus reverse force divided by sum of the masses. Forward force means here you can see M1 is higher weight and M2 is lesser weight. So this is the motion direction. This is nothing but it's called forward force. And M2 will go upside. This is called a reverse force, which means acceleration of this body is downward and acceleration of A1, same body A2, A accelerations, and this body whose acceleration is A2, which will move upward direction, which also will have the same acceleration. So first I will find the acceleration of this one. Acceleration of this body. Of course, we know the general formula for acceleration, forward force minus reverse force, to be sum of masses. It's not a general formula. It's a kind of shortcut which we can use to solve the problems quickly. Forward force means this is a mass. What is a force which is coming downward? It's weight. Weight is nothing but it is called M1G minus reverse force. So reverse force means opposite directional force, M2G divided by M1 plus M2. Is a formula, you can use it. Now question is like what is the acceleration of the center of mass? So acceleration of the center of mass is M1A1 minus M1A1 minus what will come? M2A2. Why I am writing minus will be here? Because if one direction, if one is taken as in the positive direction, other is taken as in the negative direction, because both are moving in the opposite direction, divided by mass here positive or negative. It's still positive because we are not removing any masses. Masses will be there, right? Here the negative signs because of the acceleration direction changes. So how we got this formula? We have a center of mass formula, XCM will be there. If you are differentiating XCM, what we'll get? We'll got VCM. The root is like this one, XCM. If you are differentiating, what we'll get? We'll got VCM. If you are differentiating with the VCM further, what you will get? ACM. Acceleration. So differentiation of displacement velocity, velocity differentiation again acceleration. So both left hand right hand side of this general equation of center of mass, if you are differentiating, you will get acceleration. Now we'll substitute the values for this one and we'll see what are the answers we are getting. We know it is M1, so no change. Accelerations, it is nothing but A. Already we know both bodies having the same acceleration. M2A divided by M1 plus M2. We'll simplify this part, will be here M1 minus M2 divided by M1 plus M2 into, only term is common here, acceleration. This acceleration's values I already know from this equations. So I'll substitute this one. What is that equation? M1 minus M2 whole divided by M1 plus M2 times of G. If we are simplifying this one, both are equal quantities, we can directly multiply M1 minus M2 divided by M1 plus M2 whole square times of G. This is the final answer for this question. Let's go back to this question and we'll see whether we are getting the same answers. M1 minus M2 divided by M1 plus M2 the whole square into G. Yes, it is available as option A. Okay, remember this model of questions which may ask for Neet and JEE examination.